Hello dear students, welcome into the third lecture on high performance liquid chromatography. Myself Mr. M.S. Bale. I am working as an assistant professor at Gokhale Education Society's Arts, Commerce and Science College, Jawar. So in previous lecture we have seen instrumentation and some components of that HPLC instrument. So in this lecture we are going to see remaining components of that HPLC components and its applications. See, there is fifth number component, that is column and column packing. That means what will be the material used for making that column and what type of stationary phase will be used for the packing of that column, that we are going to see now. Actually, the column length is about 10 to 30 centimeter and 4 to 10 in diameter. Are made up of stainless steel or either glass. See, the column length will be up to 10 to 30 centimeter and its diameter 4 to 10 and that will be made by material stainless steel or either glass. Normally, the columns are straight with added length. That means if we require extra length of that column, we can add the extra column, or you can say length of that, or you can say extend the length of the column. Then the column packing material used for column packing may be, that means this is the, just we have seen the material. By using that we have to made the column is diameter and length. Then for making stationary phase we have to use different type of material. Here two types of material will be used, that will be the porous bed material and pellicular bed material. Okay, now we will see these two one in detail. See, column packing material, we have seen there is two type, porous bed packing material and pellicular bed packing material. So first of all we will see porous bed packing material. So in this case, porous solid adsorbent like silica gel and alumina are used for separation of compounds of relatively low molecular weight and low polarity. See, this porous type of material will be useful for what? Low molecular weight compound and low polarity compound. The most common type of packing for HPLC column is silica gel beds of diameter up to 5 to 10 micrometer. In this, the common type is what? Silica gel bed. Silica gel, that will be creates a porous nature, is having diameter 5 to 10 micrometer m. So this is porous bed packing material. With the help of that we can made a stationary phase in HPLC column. Now the second type, pellicular bed packing. In this case, the pellicular particle is used for made up of made up of glass beds supporting material of diameter of about 40 micrometer coated with thin layer of porous material like silica gel and alumina can be used as a pellicle on solid support. See, the supporting material actually used as a glass beds. That means glass material will be used to make a pellicular what? Solid support, which is having diameter about 40 micrometer, which is coated on inner wall of the porous material like silica gel and alumina. That means that glass we have to mix along with the silica gel and alumina, that will be used for a pellicle on solid support. Then it has an improved efficiency, that increases efficiency of the column. The glass bed can also be coated with thin layer of liquid stationary phase is chemically bonded to the solid support so that it is not washed away by mobile phase under high pressure. See, the glass bed material which is coated on thin layer for making liquid stationary phase that is chemically bonded, then that material we cannot wash easily with the help of mobile phase under high pressure. So this is the material, pellicle material. By using that we can make the stationary phase in HPLC column. Now we will move to the next. Component will be the detectors. In this HPLC instrument there are two types of detector will be used. In that case, first one is the UV detector and second one refractive index detector. So a chromatographic detector is a device which is indicates separated components in column effluents. For that there will be first detector will be UV detector, ultraviolet detector. These detector based upon absorption of ultraviolet or visible radiation. That means this detector will absorb that ultraviolet or visible radiation. These detectors are used when compound absorbs UV or visible radiation in 170 to 700 nanometer region. That means these detector only works in between the range of what 170 to 700 nanometer. Now we will see the schematic diagram of that UV detector. See that diagram. So this one will be the schematic diagram of UV detector. In this case, first we will see the components. See, this is the radiation source, or can say UV source. This is the lens. Here in this part there is a sample inlet and outlet. In this part also the solvent inlet and outlet. These are the quartz window. These are the what quartz window. This one. This will be the quartz window entrance and exit also. This is quartz window. Here is the UV filter that will be filter out the UV light. Here the actual part of that detector. Now we will see it's working. This radiation source emit ultraviolet light in all direction, right? That light will fall on this lens. This lens will be convert all light in one direction. In this direction it will convert all direction light in one direction. That light will first of all falls on this quartz window, then that going through that window and directly reaches up to the UV filter. But in between this half part, this half part will be the sample inlet and outlet, and this half part will be the solvent inlet and outlet. This part, so solvent inlet and outlet. In case of sample coming through in the direction and going out like this. At that time what will happen, whatever UV light coming by this into this direction will fall on that sample. If present on that in along with mobile phase, that will absorb the UV light and showing its characteristic chromatogram, or you can say a signal, or you can say characteristic radiation emitted which is passing through this exit quartz window and falls on this UV detector. But in this side only solvent, that means mobile phase. See, we have seen in block diagram of the HPLC instrument the flow splitter will be there, right? In that case half part of the mobile phase will be going through this inlet, or you can say solvent will be going through this inlet and going into the out from this detector. See, that means only mobile phase in this will be going inside and out, going outside. See, that means this part will be the sample part and this part will be the reference part. That means sample cell and reference cell. That means sample cell whatever samples will be present into the column, it will show that much peak into the graph, or you can say chromatogram, but this solvent will show only one peak, or depends upon the solvent we have used, or you can say mobile phase we have used. According to that, it will show the peak. That means there will be actually two or many compounds if present, there we will get that peak along with the mobile phase peak. That both the lights, that means UV light which is passing through this exit quartz window and falls on this UV filter, this UV filter will filter out that UV light, and only the sample component light which is absorbed by sample and the mobile phase that will be passed and reaches up to this main part of the detector. It will detect the light and show will be the chromatogram into the graph. So this is the schematic diagram of UV detector. The light source is a low pressure mercury lamp. That means the light source which is used as a mercury lamp, or can say mercury vapor lamp. The light source falls on quartz window, passes through reference and sample cell. UV filter absorbs unwanted radiation and is sensed by dual photo cell, or you can say detector. Finally, detector will detect that light. Now we will see the advantages of UV detector. What will be the advantages? There are four main advantages of this UV detector. First one, they have a wide linear range. Second, an UV detector measure up to 0.00005, which is equivalent to ppb. That means parts per billion detection limits. See, it's having very low detection, or can say very minor detection limit up to the parts per billion. Third one, they can be used for gradient illusion. All of you know gradient illusion. That means two or more solvents we can use for this gradient illusion. They are commercially available. So this is about the UV detector. Now we will see the second type of detector, that will be the refractive index detector. Okay, before seeing this working of that, first we will see the diagram of that refractive index detector. See, this one will be the schematic diagram of the refractive index detector. First component is the light source. Here is the light source, here is the mask, lens. Here will be the half part of this will be sample cell, half part will be the reference cell. Here is the mirror, here is the optical zero and amplifier. Here will be the recorder. In the recorder it will show the chromatogram. So light source, it will emit light which is going through this mask and falls on this lens, right? This lens will be, this is convex type of lens. It pass the light, or it will pass the light on sample part, sample cell, and also the reference cell. Through the sample cell, that light falls on sample component that will absorb the light, and emitted light will falls on the mirror, and which is directly passing to this zero adjustment and reaches up to this part, detector part. Likewise, in reference cell also, the light falls on the mobile phase that will absorb light and falls on mirror, and which is passing through that, and it will reaches up to the zero adjustment. This will be useful for what? To make either zero or read the light. So that emitted light by the sample and the mobile phase, that will be amplified into this amplifier, and that will be record into this recorded through the, or can say we will get the chromatogram of that all the components along with the mobile phase. See, this is the schematic diagram of refractive index detector. Now we will see actual its working. So the refractive index detectors are based upon the change in the refractive index of the solvent that is caused by the analyte molecules. That means refractive index in air and into this sample, see that actually measured with the help of this detector, the solvent passes through one half of the cell on its way to the column. The eluate falls through the other chamber. The two components are separated by a glass plate mounted at an angle such that the bending of the incident beam occurs if the two solutions differ in refractive index. The beam reaches to the detector which is amplified and recorder provide the chromatogram. That means at the end we are getting the chromatogram of the all separated components. So this is about the refractive index detector. We have seen the diagram, schematic diagram of a differential refractive index detector. Now we will see its advantages of refractive index detector. First one, it is very stable one. It is simple to operate and sample not destroyed. It gives a response to all solutes. It is commercially available. One disadvantage is there of this refractive index detector. All refractive index detectors are highly temperature sensitive and generally rather than selective. Last component that will be the recorder. All of you know the function of the recorder. The function of the recorder is to record the chromatogram of the sample. This is the function of the recorder of the HPLC instrument. This is the last component of the HPLC instrument. Here the instrumentation part of the HPLC will be computed. Now the last part of this topic, that will be the applications of the HPLC. See application number 1. In liquid partition chromatography with HPLC techniques, separation of moderately polar substances is possible. Second, a lot of work has been carried out with ion exchange HPLC combination. Morphine, heroin, etc. have been separated on special type of resin GPAX SAX. That means in combination along with the ion exchange and HPLC, morphine and heroin we can separate out by using a special type of resin, that will be the what? GPAX SAX. That is the trade name of the resin material that will be used in ion exchange chromatography. The method is particularly useful for biochemical compounds that would be decompose if vaporization was attempted. Example, lipids in fat soluble vitamins can be separated by HPLC. Identification of toxic or decomposition products in consumer product can be effectively carried out by HPLC. Example of that, alpha toxin, highly toxic substances produced by fungus or on grain and peanuts can be determined by HPLC. This is the fourth number application. Now we will see the fifth number application. The main use of HPLC is in pharmaceutical and pesticide industries. Example of that, first one, HPLC is used for separation of a mixture of isocyanates. Second, it can be detect pentachlorophenol, that is PCP, a highly toxic chemical at less than 1 ppm in water. Third one, HPLC offer a rapid method of analyzing aspirin tablet for the presence of salicylic acid, a decomposition product that forms after long period of storage. Last number, that is 6. HPLC is used for the separation and analysis of steroids, carbohydrates, dyestuff, polymer, insecticides. These are we can easily separate with the help of HPLC. So these are all the applications of the HPLC. Thank you, dear students.